Section 4.5 Exponential and logarithm equations. Common log on a calculator. You guys need a scientific calculator, okay? Scientific, not the graphic calculator for this class. And you need to know how to use your calculator to find the log. Usually in most books, we didn't write down the base for the log. And it's understood to mean the log base will be the 10. Okay, if I put log 21, we're gonna know that will be the common log, which is gonna be the 10 will be the base. Same idea when you guys using the calculator. When you put log 21, that means we do have the base of the 10 like here. On most calculator, the key for common log is marked the log log. It depends on your scientific calculator. My calculator, I'm gonna plug in the log and then 21 and then enter. I'm gonna got the answer. But some calculator, you may input the 21 and then put the log. Now, I want you guys try to use your calculator to approximate each number to 4 decimal space. Okay, 1 to 4 decimal space. So, you enter the number and press log, or you press the log and enter the number. You should find 3.3722. Okay, this one, log 130 divided by log 0.35. You should get negative 4.6365. Okay, right? Example 2. Use a calculator to approximate 10 to the power of 2.15 to 4 decimal space. For this one, when you guys using the calculator, you could put down the 10 and then you should find a button looks like this one. Okay, this is means to the power of, and then I'm gonna put the parenthesis 2.15 and then press enter. Okay, try it on your calculator. You should get 141.2538. Okay, the number E. E is approximate to 2.71828. Okay, we call this is exponential. The number E, you're gonna see E to the power of 1. That will be approximate 2.71828. Find it from your calculator. You should find it from your calculator. That's a E to the exponent x. You should find this on your scientific calculator. You may want to press your calculator, E to the power of 1, and then hit on enter. So you're gonna get this number 2.71828. Okay, make sure you guys know how to use your calculator to find the E. The base, E, and natural log on a calculator. From the previous session, we learned that we have the log with the base A of x. And then if we didn't specify for the A, and then the common log will be the 10. If we use the E as the base of the log, then we're gonna say this is gonna be the natural log. And then we're gonna put the ln, okay, ln. So you could see natural log of 21 will be equal to log with the base E of 21. You should find it on your calculator. That's ln. Okay, one more time. The log, the common base, supposed to be 10. If you put the E instead of the 10 here, that will become the natural log. They are equal to each other. Okay, these two guys. So ln 21 will be equal to the log with the base of E of 21. Now, I want you guys try to use your calculator to approximate natural knot 712 to 4 decimal space. For my calculator, I'm gonna enter 712 and then press the LN. On most graphic calculator, we press LN first, followed by 712 and enter. Depends on what kind of calculator you guys using. So you should get 6.5681. Example 4. Use a calculator to approximate e to the power of negative 1.33 to 4 decimal space. For my calculator, I'm gonna enter negative 1.33 and then press this button. Okay, or some calculator, you may want to press this button first and followed by the numbers. And then enter. You should get 0.2645. Property of log. If x strictly greater than 0, y and a is also strictly greater than 0, and a not equal to 1, then the following holds. When x is equal to y, this is equivalent to log with the base a of x equal to the log with the base a of y. Okay, when x equal to y, you could take the log for both sides with the same base here. Now we want to know how to solve exponential equation. Okay, I have a x to the power of x equal to 21. So either you could take the log or we could try to take the natural knot for both sides. Okay, natural knot, the base will be the e here. Okay, that's a e here. And then the x, that will be the exponent. So we could put it in the front. We want to find out what is your x, so we want to isolate the x. We divide it by natural knot 8 for both sides. Okay, then use your calculator. That will be 1.464. On the exam, I only need you guys keep this one as your final answer. Okay? Okay, one more. Give the solution in terms of the ln, okay? You do not need to use the calculator. Same idea, we don't have the same base here, okay? So we're gonna take the natural knot for both sides. And then we're gonna use the power property. Put the exponent to the front. When you put it in the front, make sure you put the parenthesis, okay? This is a 2x minus 3, the whole thing, multiply the natural knot 5. And same idea with this guy, okay? Put the parenthesis. And then we're gonna distribute it 1 by 1 here. Now we're gonna combine the x to the same side here. Okay, so we subtract x, ln x, and then we're gonna add 3 ln 5 for both sides. We want to find out what is your x, so we try to factor out the x, take out the x here. And then divide it by the whole thing. Okay? This is gonna be our final answer. Example 7, one more. Okay, we do have the same base here, right? And this is a multiply. So we could just add up the exponent. Remember the formula a to the power of m times a to the power of n. When they do have the same base and they multiply it, you could add up the exponent. So this is going to be 4x plus x minus 1, which is 5x minus 1. And then this guy, you could divide it by e for both sides. When you divide it by y for both sides, this is going to be -1 minus 1, which is going to be -2. Now, we're going to take the ln for both sides. Same idea, power property. Put it in the front with the parenthesis. Okay, you're gonna see, hey, where's the ln e? You could try to use your calculator. ln e, this guy, that will be equal to 1. Okay, when I put it in the front, times ln e, which is means times the 1 here. Okay, and then we're gonna add 2 for both sides, divided by 5. Example 8, solving an exponential equation. And this is quadratic in form. Quadratic equation, remember the form? That will be ax squared plus bx plus c equal to 0. And then we're going to use the x method, right? But for this one, we do have an exponential equation with the quadratic form. So what we're going to do, first, we always look at this guy in the middle, this one. We're going to let u equal to e to the power of x. And then, since we have a square here, we're going to take square for both sides. Okay, take square for this guy, take square of this guy. So that will be u squared is equal to e to the power of 2x. Okay, so this one, that will be equal to u squared. So I have a u squared minus 6u plus 5 equal to 0. We try to rewrite it to the quadratic equations. And then factor out. So you should get u minus 1 times u minus 5. And u will be equal to 1 and 5 here. Okay, we are not done yet, right? We want to find out what is your x, not the u. So we're going to plug in back to the u equal to e to the power of x. Okay, first, we're going to plug in 1 here. U equal to 1. So e to the power of x is equal to 1. And then we're going to take the ln for both sides. And then x, put it in the front, the power property. Remember what's the ln e? ln e will be equal to 1. So x equal to, try to use your calculator. ln 1, that will be equal to 0. Okay. Okay, now we're going to try to find u equal to 5. So e to the power of x equal to 5. Take the ln for both sides. Same idea. X will be equal to ln 5 here. Okay, once we're done, we try to put it back to the original equation to see if we're going to get the true statement. So first, check x equal to 0. We're going to put it here. So 2 times 0 is equal to 0. E to the power of 0, that will be equal to 1, right? So 1 minus 6 plus 5. 0 equal to 0. So this is good. This is the true statement. Okay, this guy. And then we have a E2 ln 5. The 2, this is gonna be the exponent, right? So we could write one more step. That will be e to the power of ln 5 squared. Okay, this is gonna be the exponent. And then ln 25. When you have a e to the power of ln, this guy, that will be equal to 25 here. Okay, I need you guys to remember this. When you have a e to the power of ln 5, e and ln kind of like cancel out. So you're only left with the 5 here. Same idea with this guy, right? Combine the like terms, so you're gonna get 0 equal to 0. Okay, so both values checked. So the solution is gonna be 0 and ln 5 here. Example 9. Solve each equation. Give exact values. So we have a 4 ln x equal to 36. Since we have the constant here, so we're gonna divide it by 4 for both sides. Okay, we try to write it out. This is gonna be, we try to rewrite it to the exponential function. So remember what's the base here? The base is gonna be the e, right? So we have an x equal to e to the power of 9. Okay, use your calculator, or you could just keep this one as your final answer. Okay, same idea this one. We're gonna transform it from the log function to the exponential function. So we have 3 to the power of 1 equal to this guy here. Add 5 for both sides. Take the cube root. You're gonna get x equal to 2. Okay, example 10. We have a log A plus log B equal to log C here. Okay, we can't do anything for it. So remember we have the formula from the last session 4.3. When you have a log A plus log B, you could multiply it to become log AB, right? Okay, log A times B. And then we're gonna distribute the x. Since both of them we have the log, so we could take it out. Alright, it's just like when we have these two numbers, we could take the log for both sides. That's the same idea. And then we're gonna combine the 9 terms. So you find x equal to plus minus 2. But remember that for the original equation here, the x has to be strictly greater than 0. We can't have the negative number for the log. Okay, when x equal to negative 2, this is become negative or negative here. So the negative 2, we're gonna reject it. So we only have one final answer, x equal to 2. Okay, one more. So we have a log A x equal to y. So try to rewrite this log function to exponential function. So we have the x, the whole thing here, equal to 3 to the power of 3. Distribute it, combine the 9 terms. Now I want you guys use the x method to factor out this guy. You should get this. So x equal to negative 13 over 4 and 2. We got the negative, okay, but don't reject it yet, okay? We try to put it back to the original equation to see if we're gonna get the error. So let's check the solution together. So we're gonna check x equal to negative 13 over 4. We put it back to the original equation. We have a not 3, 4 times 13 over 4 plus 1. Okay, and then negative 13 over 4 plus 1 equal to 3. And I want to know if this is equal to each other. So not 3 cancel out. Negative 13 plus 1. And this guy, that will be negative 13 plus 4 over 4. Okay, make sure you have the blanket. Okay, and then log 3. This is gonna be negative 12 times negative 9 over 4 equal to 3. Okay, simplify it. Negative, negative become positive, and this is gonna be divided by 4. 3 times 9 equal to 3. Okay, and then 27, that will be 3 to the power of 3 equal to 3. And then this is gonna be the exponent. We could put it in the front. Not 3, that will be equal to 1. Okay, so this is good. This is gonna be the correct answer. Same idea with this one. Plug in x equal to 2. Okay, you're gonna do it by yourself. You should get both of them are the solutions. Okay, how about this one? Same idea. We have a log A plus log B, so we want to combine it. Okay, log A plus log B equal to log AB. And then we rewrite the log function to exponential function. So we have this guy equal to 2 to the power of 3. Distribute it, combine the 9 terms, factor out. This time we're going to use the quadratic formula. So plug it in. You should get x equal to 11 plus minus square root of 65 over 4. Okay, the negative, when you have the negative numbers, you can try to use your calculator. When you plug in back, you're going to get the negative number. And that's why we're going to reject the negative. So we only have a one solution. So this one, we do have an exponent, ln x. Okay, this is the exponent. So we could put it in the front, right? So you're going to have a ln x times ln e. Remember what is ln e? That's going to be equal to 1. Okay, so you only have a ln x here. And then log a minus log b. So that will be log a over b. Okay, a over b here. Both sides, they do have the ln, so we could get it out. Multiply x minus 4 for both sides. Okay, times x minus 4 here, you distribute it. Combine the 9 terms, you're going to find out x equal to 5. So you could check your work, plug back to the original equation. Okay? That's it.